Assalamualaikum warahmatullahi wabarakatuh to Dr. Narfaradila and my friends. For our presentation, first of all, I am going to introducing myself and my team members. My name is Nur Nadia and my team are Nurul Izzati, Balkis Shazwani, Siti Aida and Fatin Nazifa. This part of the project, we use metric and linear programming to create problem statement. We are adding all the theories from our knowledge given in lesson, and the main problem that we use is transportation. Mathematical problem question 1 is the cost of a ticket flight to Sabah and a luggage is 500 ringgit. The cost of 2 ticket flight to Sabah including meal is 700 ringgit. Saida wants to buy 3 tickets flight to Sabah including meal and 2 luggage, and the total cost is 1,410 ringgit. Find the cost of each item using metric inversion method. Next, I will pass to Siti Aida.
So for the mathematical solution question 1, let the cost of the ticket, flight, luggage and a meal be x, y, z respectively. By given data, first equation is x plus y equal to 500, 2x plus 2z equal to 700 and 3x plus 2y plus 3z equal to 1410. Matrix A must times 0, 2 and 3 to 3. X will be x, y, z and B is equal to 500, 700 and 1410. So first step is matrix A we must find the determinant of matrix A, where coefficient 1, the determinant is 0 times 3 minus 2 times 2 and minus coefficient 1, 2 times 3 minus 2 times 3. So the determinant is equal to -4. The next step is find the adjoint for matrix A, which find the all determinants coefficient A1, A2, A3, B1, B2, B3 and C1, C2, C3. So the adjoint is equal to -4, 0, 4, -3, 3, 1, 2, -2, -2. So the next step is A divided by determinant and times adjoint matrix A. So A divided by -4, then adjoint is -4, -3, 2, 0, 3, -2, 4, 1, -2. For the adjoint, it must be multiplied by B, which B is 500, 700, 1410. So the answer is -2,000, -2,100, -2,820, 0, 2,100, -2,820. For coefficient C is 2,700 and -2,820. So all the adjoint must be multiplied. Therefore, cost of the ticket flight is 320. Cost of the luggage is 180 and cost of a meal is 30. So I will pass to Nazifa for the problem question number 2.
Okay, thank you, Aida. My name is Fatin Nazifa, and next I'm going to present a mathematical problem and solution for question 2. The problem is about Takif's family went to a family trip to Penang from Johor during Chinese New Year. They took a train to Penang at 32 ringgit per child and 64 ringgit per adult for a total 320 ringgit. Then they took a bus to Kedah at 50 ringgit per child and 29 ringgit per adult for a total of 146 ringgit. And we need to find how many children and adult in Takif's family. Okay, for the solution, we use inverse matrix. We also use 2 times 2 multiplying matrix for the ticket price and total. For x A equal to B, we need to inverse the ticket price first, which is in 2 times 2 matrix. Then we equal it to 1 divide to 32 times 29 minus 50 times 64. And then we need to multiply to 29, negative 15, negative 64, and 32 as usual. And we get negative 29 over 32, 15 over 32, 2, and negative 1. Okay, for the next part, we need to calculate B and A inverse. First, 320 ringgit times negative 29 over 32, and then we plus to 146 times 2, and multiply to 320 ringgit times 50 over 32, and plus to 146 times negative 1, and then we get 2 and 4. Okay, the result is we get the total of the Taki family is 2 children and 4 adults.
So my name is Nwaki Shazwani. I'll be explaining for mathematical problem question number 3, which we choose the problem solver using linear programming. Okay, so for the question number 3 is there's 2 factories at Johor and also Penang. So a certain commodity is delivered to 3 depots, which is A, B and C. Okay, so weekly requirements for all for A, B and C depot are 5 units, and also 4 units. Okay, so for the production capacity of factories of Johor and also Penang are 8 units and also 6 respectively, cost of transportation. Okay, so for the cost of the transportation are as below in the next slide. So to the next slide, okay, as you can see here, there's a graph. Okay, how do we draw the graph is using the constraints, the 6 constraints that we have written. So after we have point out all the constraints, we shade all the constraints, and then we get all the corner point for A, B, C, D, E and F. Okay, so for point A is 0 and 4, for B is 0 and 5, C 3 and 5, D 5 and 3, E 5 and 0, F 4 and 0. Okay, so now to find the minimum point is we need to use the equation, the Z equation, to get the total price, the total cost for the transportation. So we insert x and y using the corner point. Okay, so for A we insert 0 into x minus with 3 we insert 0 into x, 4 into y, so we get 0 minus 3 times 4 plus with 91 equals to 79. Same goes to other corner point. We insert all the x and y's, and then we get all the total cost, which is 79 ringgit, 76 ringgit, 79 ringgit, 87 ringgit, 96 ringgit and also 95 ringgit. So as we can see in the table, the minimum cost is 76 ringgit for corner point B. So we get the minimum transportation cost is 76 ringgit for x equals to 0 and also y equals to 5. So as we can see from the calculation, from Johor, 0 units to A and 5 units to B and also 3 units to C, which is total equals to 8 units. And also from from Penang, 5 units to A, 0 units to B, and also 1 units to C. So total is 6 units. So as we can see from the figure in the slide before, Johor need to be transported 8 units and also Penang need to be transported 6 units. So that's the the whole solution for this problem. Thank you.
To explain about the coding. So we use question number 1, which is involved with matrix, and we'll show you the coding demo. So this is our coding. So actually there's a lot of way or method for the solution, but for this coding we use Cramer's rule because it's easy to implement. And then here we declare all the coefficients and the determinant for x, y, and z. This part is for the input for the coefficient, so the user need to put the input. And after that, it will calculate at the determinant part, which is for the determinant x, y, and z. Next, we have if else statement, which will, once the calculation got the answer, it will display the output depend on the calculation also. For example, if the determinant 1, 2, 3, and determinant is equals to 0, it will display infinite solution. And if the determinant is not equal to 0, it will calculate all the determinant x, y, and z, divide by determinant, so you can get the answer from it. So we will show you the display input. So first here they ask the input coefficient A1, so put all the coefficient here. So we need to make sure the output from the coding and the solution is the same. So as we know earlier, the ticket flight is 322. For the luggage is 180 and for a meal is 30. So we see here the calculation display here is exactly the same as the solution that we have done before. So that's it for the coding.
So we conclude that algebra is related to real life situation, and all the methods that use is really easy for us to use. So that's all from us. Thank you.